So hello everyone, this is Varish here and welcome to Chemistry Matter Day 2. Right, so from our previous video, we know something about matter, non-matter, Big Bang and classification of matter as non-living matter, living matter, natural matter, man-made matter and that stuff. We know about it and we focused a lot on Big Bang, right? So in this video, we are going to learn something about the types of matter and some forces, some interesting forces, okay? Right, so from our first video of chemistry, or the first video of mine, we discussed about atoms, molecules, elements and compounds, right? So I'm just gonna give some recap of atoms and molecules because they are really important in this chapter. Matter is made up of small substances called atoms and molecules. Now matter which is there is made up of small substances, right? We know that from our first PPT too, we said that matter is something that is made up of atoms and molecules, whereas non-matter or energy is not made up of atoms and molecules. So that's one of the difference we saw. So atoms are the small substances, they are there. So when you break down a substance more, the indivisible, or where you cannot divide it more, the end stage is an atom, right? They are the smaller substances. They are the end stages basically, and they make up some other complex substances like molecules and elements. So if you break a molecule, you will get two separate atoms or more atoms, right? But an atom, you cannot break it more, right? It's indivisible. That's what we have discovered till now, and we even discussed the structure of an atom, right? Protons, neutrons, electrons, stuff. Okay. Molecules now. Some atoms like this hydrogen atom which is there over here. So let me take my pointer now. Yeah. So the hydrogen atom which is there over here, if there is one hydrogen atom, but if it can't exist independently, it asks the other atom for help. Now it's like, see, one hydrogen atom is there. It's like, I cannot do my homework. Then another hydrogen atom is there. Then that atom is also like, I also can't do my homework. Then they both come together and both share their ideas and do the homework. So if one atom cannot exist independently, they combine to form atoms. Now either this hydrogen atom can combine with the same type of hydrogen atom, or this hydrogen atom can combine with a different atom, that is an oxygen atom basically. So they are molecules. Now, so next comes intermolecular space and intermolecular force of attraction. Now this is really interesting, right? So first comes molecular. Now when you hear something about molecular, you need to think it's related to molecules, atoms, that stuff. Correct. Inter means between. So the space between all these stuff. See, we have got the meaning from that name. So let me tell you guys. So from this one which is there, the space between this hydrogen atom and this hydrogen atom, the space between this hydrogen atom and this oxygen atom, the space which is there between the smallest units, or the space between the atoms, the space between molecules, you can call that as intermolecular space. Intermolecular force of attraction is the attraction between two molecules, right? So if they are being attracted with each other, they are intermolecular force of attraction. They have force of attraction, right? A best example can be like, take two magnets, right? So take two magnets, keep the unlike poles, they both will attract. So over there, attraction is more. So if the two molecules are there, if they attract more, that is intermolecular force of attraction, right? Next ones. If there is intermolecular force of attraction greater than the intermolecular space, now this is simple, right? So take two magnets, same example. If you put the unlike poles, both would attract, correct? So if both would attract, intermolecular force of attraction is high, correct? But if you see between them, the space is less, so intermolecular space will be less, correct? And then put the like poles together, they will repel. So their force of attraction is less, correct? And space would be more, right? So this is what this sentence says. Now let's get to types of matter, states of matter basically. There are three states of matter: solids, liquids and gases. So first comes solids. solids are rigid or packed. So you can see a picture of a solid over here. Now they are packed. Now over here we can take a really good example, right? Okay, so take some balls. Okay, if you have some balls, you can take them up, or you can take cardboard even, that's fine. Then you can plaster it up. So when you plaster it up, you see that all of them are tightly packed. You see that all of them are tightly packed. Or if you have made some craft or something, and then you have used plaster to fix two things, then they are tightly packed. You ensure that they are tightly packed. So solids are like that. It's like all the atoms are fixed with a plaster, but it's not, right? So they are rigid or they are packed, and then they have a definite shape and volume. So you take some cardboard pieces and plaster them, and you will see that they give some shape, either a cube shape or a cuboid, or some shape. They would give some shape. Even this bunch of atoms which is there, it gives some cuboid shape, right? So when they are packed, they give some shape, and as they occupy space, they will have volume. So basically everything will have volume. Every state of matter takes space, right? So matter means anything that has weight and that has mass and takes space. So every form of matter takes space. They're incompressible. Now what is compressibility? So if you press that from both the sides, what happens is pressing from both the sides. Now that's the case over here. Let's see it. Okay, when atoms are they are with each other, or you can say they're colliding with each other, or basically they're packed with each other. When you try to compress them, you won't be able to compress, right? Okay, let me give you an example or something like that. Take a bunch of magnets, or take a bunch of cardboards and plaster them. Cardboard pieces, small cardboard pieces, you see. And then when you try to compress it, you won't be able to, because there is no space. How will the molecules go, right? How will the molecules go more? Correct? So there is no space, not a lot of space, correct? So they have less intermolecular space and a lot of attraction. Now if there is less space and they are not compressible, they have a lot of attraction between them, correct? Example: wood, coins, board, etc. Liquids. The liquids flow, so they are called fluids. Now fluids flow, so liquids flow, right? Yeah, they flow from a higher level to a lower level, or HP to LP. Now you basically have visited a playground, right? So there is a slide like thing, right? So you try to pour water from up or a higher level, then the water would flow down, correct? Yeah, that's really good. But if you try to pour water from down, it won't go up, right? It's against gravity. So it flows from higher level to lower level. But in nutrition plants first chapter, we have seen something about osmosis, right? So if there is low pressure region and high pressure region, it would always flow from high pressure region to a low pressure region, no matter the height. Yeah, this force can oppose gravity. That's it. Liquids do not have a definite shape but have a volume, right? So they take up some space, they have some volume, but they do not have a shape, right? Because you cannot catch a liquid. Even though you try to catch some water, it would be like it would be taking the shape of your hand. So you need to create something hollow, and then it takes the shape of the container, right? So liquids for them do not have a definite shape. They can be compressed to some extent, right? So over here we can see some spaces, and so they can be compressed to some extent, right? This molecule moves over here, this molecule moves over here, done. Some extent, that's what. There's some molecular space and some force of attraction, right? It's the medium level. Liquids are the medium level, not like solids, full packed and no space. They have some space, some attraction. Example: water, milk, oil. Next comes gas. Now, you have seen the difference between the molecules or atoms, right? They do not have a definite shape but have some weight, right? Yeah, even every molecule or every atom takes some weight. So they do not have definite shape, but they take some weight. They flow in all the directions and are known as fluids. So they flow in all the directions and they are fluids. Yeah, flowing and fluids, obviously. They are highly compressible. So they have high intermolecular space. So you have a lot of space here. So you can compress them, right? this molecule can move somewhere over here, this molecule can move somewhere over here, this molecule can move somewhere over here. So there is a lot of intermolecular space, so there is a lot of compressibility. And then if there is a lot of space, the attraction wouldn't be more, right? So examples can be oxygen, carbon dioxide, hydrogen, helium, any gas you can take, right? Yeah, so you can see the difference between the molecules over here. This is a solid, tightly packed, some liquid, and then complete gas. Yeah. So now this is the last slide of our day 2. As temperature increases, kinetic energy increases, and as temperature decreases, kinetic energy decreases. Now this is something really, an important point. Now you see, you take a solid or ice basically, which is a solid, and you try to heat it, right? Heat is nothing but temperature. So if you increase the temperature or provide heat, it would melt down. It would change from a solid to a liquid, right? So as temperature increases, kinetic energy increases. Now what is kinetic energy, right? So from this state, the kinetic energy is movement of atoms. So you will see that, you will observe that kinetic energy would be most in gas, right? They would be moving, and least in solid, correct? So when you heat it or increase the temperature, kinetic energy in the molecules would increase. So slowly they would start, and the kinetic energy would start increasing, right? The particles would be moving faster. So they would change from solid to liquid to gas finally, right? That's what this is. And as you decrease the temperature, as you freeze that water, then all the kinetic energy decreases, the movement decreases, particles start to stick together, right? That's what this line says. The force of attraction between different substances is adhesion. Now, different substances, you take two different substances and try to attract them, that's called adhesion. And two same type of substances, you try to attract them, that's cohesion. Now, solids have strong cohesive forces, right? They have strong intermolecular forces, so they will have strong cohesive forces. Liquids have weaker, and gases the weakest, because we know about the intermolecular force of these substances. Mercury, although is liquid, has a strong cohesive force. Yeah, that's a really good fact, right? So hope you learned something new in today's video. So we have explored a lot about some forces and all that stuff, the solids, liquids, gas. Hope you enjoyed this video. In 2 to 3 videos, I guess, we'll complete our chapter, the matter. So we'll continue the chapter in the next video. So we have some idea about matter and all that stuff. So continuing the chapter in the next video. Until then, bye bye.